Now, in this video, we're going to talk about transformation and matrices. Let A is a point with Cartesius x, y. We could transform this point to some point A accent, which coordinates A accent and Y accent, using 2 by 2 matrix. The elements are A, B, C, and D as follows. So A transformed to A accent. So A accent equal to multiplication between the multiplication between the matrix transformation by A. So X accent, Y accent equal to the matrix A, B, C, D multiplied by the matrix XY, which XY is the coordinate of A. So, for example, the coordinates of A, B, and C listed here are transformed to A accent, B accent, and C accent by matrix 1, 2, 0, 1. Find the coordinates of A accent, B accent, and C accent. As we have discussed that A accent equals to the matrix transformation 1, 2, 0, 1 multiplied by matrix A. So A accent equals to 1, 2, 0, 1 multiplied by A. Make it as a matrix 2, 1. Remember, multiplication of matrix is row times column. This row times this column. So 1 times 2 equals to 2 plus 2 times 1 equals to 2. This row also multiplied by this column. 0 times 2 is 0 plus 1 times 1 equal to 1. So the matrix transformation of A, which means A accent, equals to 4 and 1, which means the coordinate of A accent is 4, 1. Next, how to find B accent is just the same way to find A accent. So B accent equal to the multiplication between the matrix and the coordinate of B. 1, 2, 0, 1 multiple with B. Make it as a matrix 3, 2. So B accent equals to row times column. 1 times 3 plus 2 times 2. And then this row plus this column, which means 0 plus 1 times 2, 2. So B accent equal to 7 and 2, which means the coordinate of B accent is 7, 2. So the last, how to find C accent. In order to find C accent, just the same way, it's multiplication between the matrix transformation and coordinate C. So 1, 2, 0, 1 multiple of coordinate C. We make it as a matrix 0 and 1. Remember, multiplication of matrix row times column. 1 times 0 equals to 0. 2 times 1 equal to 2 plus 2. This row times this column. 0 times 0, 0 plus 1 times 1 plus 1. So C accent equals to 2 and 1, which means the coordinate of C accent is 2, 1. So, how to find the inverse of a transformation matrix? If matrix T is the matrix transformation point A to A accent, T inverse will transform A accent back to A. So A accent equal to T multiple with A. So A equal to the inverse of T multiplied by A accent. The triangle ABC is transformed to A accent, B accent, and C accent by transformation matrix where T equal to 3, 1, 1, 1. If A accent, B accent, and C accent's coordinates are listed there. Find the coordinates of A, B, and C. As I said before, that A equals to the inverse of the matrix transformation times A accent. In order to find the inverse of T, we have to find determinant of T first. How to find the determinant of T? Determinant of T is the product of this number subtracted by the product of these numbers. So 3 times 1, this diagonal, minus this diagonal, 1 times 1, equal to 3 minus 1, equal to 2. Inverse of T equal to 1 per determinant of T multiple by, switch this diagonal 1 and 3, and then multiple these numbers, the number of this diagonal with negative 1, negative 1 and negative 1. 1 times negative 1, negative 1. 1 times negative 1, negative 1. You simply just multiply by negative, okay? So, equals to 1 per determinant. We have known determinant equal to 2. 1 per 2 multiple by this matrix. So, after we found the inverse of T, we just find A with multiple the T with multiple of inverse of T, which this number multiple by A accent. A accent is 22 and 10. 22 and 10. Make it as a matrix. You just need to mind the matrix. Just leave the half first. Just leave it first. Okay. Remember how to multiple two matrices? Row times column. Okay. So 1 times 22 is equal to 22 plus negative 1 times 10 equals to negative 10. And then this row times this column. Negative 1 times and 3 times 10 equal to 30. So A equal to a half multiplied by this matrix. 22 minus 10 equals to 12. Negative 22 plus 30 equal to 8. Okay, remember multiplication of scalar in matrix. This is the scalar. You just simply multiply the scalar to each and every element inside the matrix. So A equals to 6 and 4. So the coordinate of A is 6, 4. That's the answer of A. Now you find the coordinates of B and C in your worksheet. Triangle PQR is transformed to P accent, Q accent, and R accent by matrix 1, 3, 0, 1. Triangle P accent, Q accent, R accent is transformed to P double accent, Q double accent, and R double accent by matrix 2002. Find the triangle matrix that will transform PQR directly to P double accent, Q double accent, R double accent. So for this kind of a problem, we take one of the point. Let's say we take P. Let's point P. Coordinate of P is x, y. So P transform to P accent by this matrix. 1 3 0 1, and then P accent transform to P double accent by this matrix 2 0 0 2. So the question asks the single matrix that transform P to P double accent. Or the other hand, if we use the coordinates x, y transform to x accent, y accent transform to x double accent, y double accent. We're going to find the single matrix that transforms xy to x double accent, y double accent by one matrix. So we have known that if we transform x to x accent, which means we know that x accent, y accent is transformed from x and y by this matrix, the matrix 1 3 0 1. X double accent, y double accent is transformed from x accent, y accent, from p accent. So by this matrix 2 0 0 2. Now we substitute this matrix with this equation. So x accent, y accent equal to this one. So x double accent, y double accent equal to this matrix. This we substitute with this one because x accent, y accent, x accent, y accent equal to 1 3 0 1. So the matrix that transform x and y directly to x double accent and y double accent is the product of these two matrices. If you find the multiplication, you will get 2 6 1 5 x y. So this is the matrix that transform x, y directly to x double accent, y double accent, which means this is the matrix that transform P directly to P double accent.